part of your factoring review is factoring trinomials. Trinomials are polynomials with 3 terms, and they're usually in the form ax squared plus bx plus c, where a, b, and c are all real numbers. So factoring is related to multiplication. A quadratic trinomial can be factored by working backwards with the FOIL method, so using guess and check. So again, like we looked at before, when we multiply 2 binomials, we end up with a trinomial, usually in the form ax squared plus bx plus c. So we're going to look at some steps for factoring trinomials. It does take some guess and check, but we have different numbers that we can use for that guess and check. So the steps for factoring trinomials, again, you may have been taught a different way. This is the way that I teach because I think it makes the most sense. If you have another way that makes sense to you, by all means use that. If you have questions about your method, make sure that you ask me because I can clarify. So the first step is find the factors of your first term. So that's the first number, usually our ax squared. And we're going to write those in the first column. So we're going to write out a plus sign, as you'll see on the right here. And the factors of your first term go in the first column. We're going to look at examples of how to use this in just a minute. The second step is to find the factors of your last term, and those are going to go in your second column. The third step is to cross multiply, and that is so we can check your middle term, and that's going to be your x term. And then lastly, if it works, you're going to write the factors from the top and the bottom rows. So let's put this into practice. Now remember, when we first factor, the first thing we should always look for is a common factor. So in part A, we have x squared plus 14x plus 40. Notice we don't have any common factors, so we have nothing to factor out. The second thing you're looking for is perfect squares in your pattern like we talked about in the last section. Notice we don't have any perfect squares, so then we move on to using our T method or factoring trinomials. Notice we have 3 terms here, so it is a trinomial. In the first column, we're looking for the factors of our first term. So our first term is x squared. The factors of x squared are just x times x. So we're going to write an x in each of those boxes to make the first column. Second step, we're looking for factors of our last term. So that is 40. So we're looking for numbers that we multiply together to get 40. So we know that 1 and 40, 2 and 20, 4 and 10, and 5 and 8 will all work. Now we're looking for a combination that's going to give us a middle term of 14x. So if we look at our combinations, 4 and 10 make 14. So we're going to write those in our second column. Now I said the third step, we are going to cross multiply and check. So we're going to cross multiply. 4 times x is 4x. 10 times x is 10x, and we're going to add those together. 4x plus 10x is 14x, so that does work. So our factors again come from the top row and the bottom row. So our factors are x plus 4 and x plus 10. Again, we can multiply it out to check. If we multiply it out, we should end up with our starting problem. For part B, we have 6x squared plus 7x minus 3. Again, we look for a greatest common factor first. Notice there's no common factor that they have, so we're going to set up our t because we have a trinomial or 3 terms. Again, we're going to first start with our first term. So we have 6x squared, so we're looking for factors of 6. We know that they're 1 and 6 and 2 and 3. And then x squared we know is going to be x and x. So we just need to figure out which combination, either 1 and 6 or 2 and 3. I'm going to start out by trying 2 and 3 because we also have to look at our last term. Our last term, notice, is a negative 3. So we have to look at the combinations that we can get a negative 3. We know that to get 3, we need to multiply 1 times 3. To get a negative 3, one of these numbers has to be negative. So let's say negative 1 times a positive 3. Now we could also get a negative 3 by taking a positive 1 and a negative 3. So either of those combinations would work. Now the way we determine which combination works is again by cross multiplying to check. So we just need to try one combination. Now I'm going to try negative 1, 3, and I'm going to put negative 1 on the top and 3 on the bottom. And then I'm going to cross multiply to check. So 2x times 3 is 6x. 3x times negative 1 is negative 3x. And that will give me a positive 3x. Now notice our middle term is positive 7x. So this one does not work. So I need to try a different combination. Now before I try a different set of numbers, I'm just going to flip these. So I'm going to do 3 on the top and negative 1 on the bottom. So if I have 3 and negative 1, I'm going to cross multiply to check again. 3x times 3 is 9x. 2x times negative 1 is negative 2x. 9x minus 2x is 7x. Notice they match, so that is my combination. So my factors are 2x plus 3 and 3x minus 1. Again, if we multiply it back out, we should get the original problem. Part C, we have 2x cubed plus 16x squared plus 24x. Again, we want to look for a common factor first. Notice they both can be divided by 2. They can also be divided by x. So I'm going to factor out a 2x. So my first term, if we divide that out, the 2's will cancel out to be 1. I'm left with x squared. 16 divided by 2 is 8. X squared divided by x is x. 24 divided by 2 is 12. And x divided by x is 1. So now from here, I'm going to factor this trinomial. So I'm going to set up my t. On the left-hand side, we want factors of our first term, which is x squared. So that's going to be x and x. On the right-hand side, we want factors of 12. So I could do 1 and 12, 2 and 6, or 3 and 4. Remember, we want 8x as our middle term. So I'm going to use 6 and 2. If I cross multiply, 6x plus 2x is 8x. So that gives us our middle term. So don't forget to put your common factor out front, so 2x. And then my factors are x plus 6 and x plus 2. Again, if we multiply this back out, we should end up with your original problem. And our last example, 3x cubed y plus 18x squared y plus 27xy. So notice we have a common factor again here. We can divide them all by 3, x, and y. Divided about, 3 divided by 3 is 1. X cubed divided by x is x squared. Y divided by y is 1. Next term, 18 divided by 3 is 6. X squared divided by x is x. And y's cancel out. And last term, 27 divided by 3 is 9. The x, y's cancel out. So now, notice I have a trinomial, so I'm going to set up my t. So on the left-hand side, I have my x squared, so I have x and x. On the right, I need factors of 9. So I have 1 and 9 and 3 and 3. Notice my middle term needs to be a 6. So I'm going to try 3 and 3. 3x plus 3x we know is 6x, so that works. So my final answer, again, my common factor goes out front. And my terms are x plus 3 and x plus 3. Now notice the x plus 3's are repeating. So we write this as x plus 3 quantity squared. So it's just like saying x times x, which we don't write as x times x, we write it as x squared. So your final answer, 3xy times x plus 3 quantity squared. So to factor in general, the basic steps are first to look for a common factor. So if you have a common factor, factor that out first. Second, you're looking for perfect squares. If you have perfect squares, you're going to use your perfect square formula that we talked about in the second part. And lastly, if we have a trinomial, you're going to set up your t and factor using the t that we just talked about.